Okay, now here we will understand what is normalization and why we need it. The first question arises why we need the normalization. This is a small table. You can see roll number, name, age, branch ID, and we can add one more. We can add one more um, column with the name HOD, and the name is A because this is a CSE branch. So we can say the HOD name is A for all. So, why we need the normalization? Normalization is basically is the method to split the table in two or three so that the one record is uniquely identified uh, in the entire database. And there are few anomalies. Anomalies is a that there are few things that should not exist in the table. When we update the table, let's suppose there are three kinds of anomalies: update, deletion, and insert. There are three types of problem with this table structure, which seems good, but there are problem with this. Let's understand this first. When we update the table, let's suppose today's HOD is A, and tomorrow the new HOD comes, and it is now B. Okay, it is now B. By mistake, if we updated all the records with the HOD B, and by mistake if the fourth record left for updation, then what will happen? So, or another condition we can take that branch ID today is 101. Okay, there is some case that we need to add we need to update the branch ID for some reasons. So to 102, we start updating it to 102, 102, 102. We have updated it. Okay, but with some reason that I forgot to update this 101, what will happen? It's easy to update the record when we have the same kind of record, but when we have like ECE branch, when we have EEE branch, okay, and their code is 105 and 106. So in this case, right now you can see in the table that if we update the table with the branch ID at 102 and the one record remains as it is, we forgot to update the one record. What has happened in this table? That CSE branch is 1 and its branch ID is 2. It is not unique. So branch ID is 2, that is 102 and 101. So that is the update issues with this table. So we need to understand, we need to check each and every record to while updating. Okay. So this is the problem with the updation. Okay. Suppose now, what is the problem with the insertion and deletion? In the same way, when we delete a record, okay, I said I don't want Anmol, okay, whose age is 23 and branch is CSE or 101. Okay, let's not take this. Take another equation. We say that there is one more record. After Bhuvnesh, I say that there is one more name is Aryan. Aryan of age 23 and he is studying in ECE. There's one more record, uh, Jay. Okay, his age is 25 and he's studying in EE. So this is the entire table. This is the entire student record we have. So what happened if I delete this? I said Jay is leaving and we had need to delete this record. So if we delete this record, okay, what will happen? That EE branch is completely out from the college. This branch is completely out of the college. So now you understand the problem. If we are deleting one record For this, and this the branch and branch ID is being deleted. Okay, while the branch is available in the college, but because there was only one enrollment, and that enrollment is gone, so the system deleted the branch also. And if we want to see from the record that how many branches are in the college right now, so it will just give you two options, CSE and ECE. These are the only two options that we have right now, and there are only two branches that we have in our college, because EEE is not in the system. So this is a deletion anomaly. This is a deletion problem, and what the same is the insertion problem. Okay, when we insert a new record and the person is from the ME branch, so in that case we need to define the ME branch, and we need to define the branch ID also. So understand the issue that even if we are updating, we are deleting, and we are inserting all the way, we are from all the senses. If there is one record for the one branch, if there, suppose if there is one enrollment in ECE, uh, so while inserting we need to type the ECE branch, because there was only one record. Before that, ECE branch was not present in the table. So, and also the branch ID was not present in the table. So this is the anomalies that we have, generally we do have in the uh, tables, and that is why there's a requirement of normalization. We need to normalize these tables so that this becomes okay. Okay, there are four kind of normalizations. Okay, okay, there are four normalizations: first normal form, second normal form, third normal form, and first normal form. First learn about the that table, the same table. That what does table says that roll number, name, age, branch ID, and HOD. Okay. What I did? It's divided this table into two tables: roll number, name, age, branch ID. Okay. This these three and this, and we have added another table with the branch ID, branch name, and HOD. Now for the branch 105, which is ECE, HOD is B. Okay, and for the branch 106, let us understand this. For the branch 105, which is ECE, ID, name, and what was that? HOD. Okay, so HOD is now B. 106 EEE, and the HOD is C. 101 CAC, HOD is A. So if we know, if we delete, if we update the HOD over here, that now the HOD is not A, it is D. Okay, so this is the one record that we have updated. And if we update that there is one more branch in our college, which is ME, whose HOD is E, so we have added just one record. So insertion and update is easy, and also deletion is also easy. If we want to delete a record that ME branch is no more in our college, we will just delete this record and this will be resolved. Come to this, over here we are just taking the branch ID from this table. We are just mapping this branch ID with this branch ID available. So whenever we are adding any student, we are just using branch ID at 101 if the CSC, if 102 if if the ME, or 105 for EC, and 106 for EE. Now, what happens is if we map this from this relation, we can say that the name of the branch and the HOD of the branch. So normalization basically resolves this issue, resolves this issue that we have seen. These all the anomalies that are update, delete, and insert in the two tables by dividing the attributes in the two tables so that things got easier right now. So let us understand the types of normalization. Types of normalization. There are four types of normalization: first normal form, second normal form, third normal form, and Boycott normal form. In all the four normal forms, that it has been tried that the anomalies will be removed as it grows up. So let's see the first normal form. What it says that we should not have multiple values in a single column. All the records should be atomic. All the records should be atomic. So if there is a table course and content. For the web, we have language HTML, PHP, and ASP. This should be an atomic record like this. You can see it's clearly visible. For web, HTML, web, PHP, web, ASP. So there it says, the first normal says that that arrange the we should not have this kind of data in our table. Otherwise, searching will be very tough. If you want to search that PHP is what kind of language, then this will not result out. So so avoid these, doing this kind of creating this kind of database. So the values in every attribute, in every row should be from atomic domain, every cell. Second normal form. Second normal form says that the first the properties of first normal form, and also it should be partially dependent. There should not be any partial dependency in the second normal form. Second normal form says that there should not be any kind of partial dependency. That let us understand this. There is a relation A, B, C, and D. There is two relation as the synonym of table. So there is a relation A, B, C, and D. From A, B, we are able to find D, and from B, we are able to find C. Initially, we were using AB to find CD. So we can say that AB is a candidate key. From the AB, we are able to find C and D. And you can see from B, we can find C. So this phenomena is known, this is known as a partial dependency. The second normal form says that this partial dependency should not be in the table. Is that clear? So, so okay, we can resolve this in this. This is a table: student ID, project ID, student name, and project name. And using these two, we can find these two, but we can find also project ID with the project name and student ID and student name. So there is a partial dependency in this. So we can use this kind of table structure like student ID, student name, project ID, and then project ID is mapped with this. And so this is now this is now normalized. So let's come to the third normal form. It uh, in third normal form says that there should not be any transitive dependency, no non-key attribute should be able to drive another non-key attribute. In the above example, we can say that from the student ID we can find zip, we can find city, both are okay. But from the city we can find zip, and from the zip we can find city. Though city is not a key, this is also not a key, but they are able to identify each other. So this should not happen in the as per the normalization rule. So this is a transitive dependency. This should not occur in the table. We can break it in this form: student ID, student name, zip, and we can map zip and city. We can create an entire database of zip and city in the other table, and whenever you need to identify the city name, we can identify it by using the zip, because it's a unique for every city. We need to find the uniqueness, so it is unique for the every city. You can also understand here there is a relation A, B, C, and D. So where A, B can find C and C is able to find D. Okay, A, B can find C and C is able to find D. So this is the transitive dependency. So we can resolve this in this relation by dividing it in the two relations, and these are the two relations where A, B, C is one relation and C, D is another relation. Postcode normal form is an extension of third normal form, and the bit strict. It says that no for any non-trivial functional dependency in which x tends to a, where x must be a super key. So in the following in the above record, it says that student ID, student name, student from student ID we can find the student name and zip, and from in this other table, that from zip we can find city. So here student ID is the super key and here zip is a super key. So this relation says that these both are in the Boyce Codd normal form, because both are the super keys in their own tables, and and the one is defined by other. So this is known as a Boyce Codd noun form. This is a little stricter than third noun form. Okay, let us see the examples of the normal forms. Okay, there is, you can see there is a supplier. There is a table in where you can find the table structure: supplier ID, supplier ID, supplier name, products, and type data types int varchar. Where supplier ID is one, supplier ID's name is this, and the product it is the reading and this, and suppliers. Yeah, now you can see this. So we are dividing it into the other format. So supplier ID primary key, supplier name in care, we have divided it into two parts, and there is one more table, products, where we can write the values of product. Basically, the first normal form says that there should not be multiple attributes, multiple values in one column. But let's extend it to the where we can divide these in the two tables. So if we do so, this is in the first normal form, and the record is also uniquely identified, and we can map it with the supplier ID over here and the supplier ID over here. This is the mapping. We can join these two tables. We can take the results out using these supplier IDs. Second normal form says that there should not be any partial dependency. So this is the example of the partial dependency. This should not occur. Okay. Again, in this product ID, this is the products. Okay, integer varchar, integer varchar, and varchar. Product ID, product name, store name, and price. Product ID, product name, store name, and price. And from this, store ID is remaining. I think store ID is missing. So what we can do, there must be one store ID also. So we can divide these tables in this format, in this way. I'll share the presentations also, so it will be easy to understand. This is the third normal form, and this how the tables has been divided, so that the data is in good shape. Thank you. I'll post the link of the PowerPoint presentation in the comment box. Thank you.